Well, good afternoon. My name is Tabitha Binding, and I'd like to welcome you to designTimber. This is the third in the series from Timber Development UK, where we're creating the opportunity to learn from the multidisciplinary teams behind incredible projects selected from the Wood Awards 2022. So the Wood Awards 2023 are now open for entries. So if you type in the woodawards.com and just look for entries 2023, we look forward to seeing your amazing work. So as people come into the room, I'd like to tell you a little bit more about Timber Development UK, which is formed from the merger of the Timber Trade Federation and TRADA. By bringing these two associations together as one, we've created the largest, most comprehensive supply chain body in the UK, spanning from sawmill to specifier to finished project and all points in between. Our mission is for timber to be accepted as the first choice as a suitable construction projects in the UK. To do this, we will act as an agent of change towards more sustainable, low carbon forms of construction. So we're here to connect the supply chain, to lead best practice and accelerate to a low carbon future. Which is why we're delighted today to introduce March House, which came highly commended in the private category in the 2022 Wood Awards. We have Fergus, Tim and Jonathan, who are going to take you through or talk you through a fantastic presentation on the March House. We've got time for questions at the end, so please type them into the Q&A box as we go along. And with that, I'd like to hand over to Fergus, Tim and Jonathan to tell us all about the March House.
Great. I'll just share screen. Tabitha, can you hear me all right?
Yeah, I can hear you and it's in full screen.
Testing.
So, yeah, we're here today to talk about March House, which is a predominantly timber building. It's a modest house for a single client, and it's very much about the team that delivered it. And I think that was the real success for the project, from the contractor to the design team. So today, I'm Fergus from Knox Bhavan, and we have Tim from Price & Myers, and we have Jonathan from BlokBuild. So Knox Bhavan and Price & Myers have worked on a number of projects before, but it was the first project where we worked with BlokBuild as well. Tim had recently worked with Jonathan to deliver a sculpture which is in Terminal 2 in Heathrow by the artist Richard Wilson, pictured on the right. And it was extremely complicated in its geometry. And we had a much kind of simpler, more modest proposal for this furniture and joinery within our office, which is in Peckham and done in 2016. So, did I skip? So we had two items of joinery that we needed help with, and Jonathan and his team cut out the various components. These were the mezzanine on the left, which is made of plywood, kind of laminated together, which was all CNC cut, and it had a tension strap steel that kind of intersecting underneath it that Tim engineered. And on the right is our sit-down stand-up table, which had a multiply oak top with a birch face pie chassis, which you're able to sit down and stand up at. And it all kind of becomes one long table through the length of the office. But having worked together and knowing we could work together, we then moved on to March House. So March House is on the River Thames in Peckham, to the west of London. Price & Myers and Knox Bhavan are also both in London, but Jonathan's a bit further north in Hull. Elizabeth Rose was the client, and she came to us because of a project we'd done previously in the office called Crowbrook. It has a mid-century modern feel, and that was something that she was really keen on. Elizabeth herself had an amazing collection of furniture and art, which she collated and dimensioned and gave us a real detailed specification for what she wanted in her house. She lived on the site previously for 10 years in a house which was here to the south of the River Thames. To the south of that is, you can see, if you can see my mouse here, there's a hill called Winter's Hill. And then there are floodplains either side of the river. There's a sewage works, and it's close to Peckham and Marlow. The site itself here is square with a existing house in its centre, and we had to get this right of way from the local farmer to allow the vehicles to turn into site. It's a real idyllic location. The first site visit we had when we met the client, we had dinner outside by the water, and there was kind of a regatta going past, and it was really spectacular. But there is a real issue with the site. The flood risk is real, and it does flood. It floods to different levels. So once a year, the ground becomes saturated to about maybe 100 mil above ground level, but occasionally it floods much more seriously, and the client, Elizabeth, has to wear waders to access the site or use a boat, and all the vehicles are parked up the hill. The existing house, which Elizabeth had lived in for 10 years, was in the floodplain. So the ground floor, despite being raised, was still susceptible to flooding. On top of that, the wall construction and fabric was poorly insulated and not of good use. And Elizabeth wanted a house for her family and her future needs. And that's why she came to Knox Bhavan. She had planted her garden. Elizabeth, I forgot to mention, is a fantastic gardener, and she had established on the riverside of the site here an amazing garden, as well as here her kitchen garden with a greenhouse, and much of the produce she grows on site, and she maintains and manages when it's flood conditions. So we came to the planners with a modest single-story building raised up on stilts above the flood level. You can see here, and in blue, that's the flood level line. And the proposed building is 1.7 below the existing ridge height, and the bulk is far reduced, and it sits in the site very elegantly. But it was still a real challenge to get through planning, and it took 2 attempts, mostly because of the ground floor footprint area. And we did diagrams to explain that actually the amount of displaced water was being reduced. Here you see the stilts actually displacing far less water than the proposed building. But as a result, the plan got much tighter, and the building, I think, became better as a result. And the design had to work with the flood level. So the proposed finished floor level with the red line, the green line is the 100-year flood level, and the pink line is the flood level adapted for 35% climate change on top of that. So all of the structure of the building had to be safe above that level. And we'll go into this in more detail, but the strategy for the scheme was that everything above the steel podium level, which is robust and in the water zone, is timber, and then everything below that level is the kind of resilient materials. So the proposed house is on the site with 2 ancillary buildings, a boathouse in pink and a new garden shed. And the strategy for the house was there was a main space in its core, which was orientated towards the river and back towards Winter's Hill on the south, with 2 wings either side, one which is Elizabeth's accommodation area, and then the other which is guest bedrooms and her kitchen. And this shows the before and after from the river. Another key consideration Elizabeth had was that she wanted the house to be as sustainable as possible and well insulated, and using modern methods of fabrication if it was applicable. The house itself uses a ground source heat pump. There's an on-site Clargester to deal with sewage. And there is also MVHR system, which circulates air within the building. the rest of the ventilation is done by opening shutters. I'll go into more detail about this later. High performance glazing. It's got a green roof, and then there's also the building fabric is very highly insulated. The materials, which again we'll go into in more detail, were above the steel podium level. Everything is timber to sequester as much carbon as possible and reduced its embodied carbon. So yeah, as I said before, the building is predominantly off-grid, apart from the electricity which is supplied to the road. The Spado Reach is a private road, so there's the electricity supply and BT. But the March House doesn't have solar panels, but that is something that is going to be installed at a later date as a community supplied system where everyone chips in, and there'll be a kind of collective solar panel system. And surface water drains into the Thames. So the plan is arranged with the around Elizabeth's extensive furniture collection, and this was a real key design factor, as well as working with her garden and the views around the building. So you can see here the various bits of furniture slotted into the plan. So you enter the building from where you drive in, up a staircase on the left-hand side, and you're immediately greeted by a view across the whole building towards the garden. That's framed by and that's Elizabeth's writing desk in front of that. The center of the plan has a spine wall which subdivides that middle space, and there's a roof light above it that floods light into the middle of the building. After you enter, to your left and right, to your right is the kitchen with a view towards Winters Hill, and on your left is the guest area, but this area could also be converted at a later date, well, not really converted, but it could be used at a later date for a carer if required. And the pink shows where that's timber oak lined, that section of the building, to make it distinct from the rest of the house. And you can see here that view through towards the garden on the left, and then the view from the kitchen towards Winters Hill. And all of these spaces were designed about Elizabeth's furniture and her Vitso shelving, and these door frames were oak with veneered oak paneling between them. So you then progress towards the main space, which is the kind of core of the house, and the ceiling height also changes in this space. It's popped up, and the two orange areas are where the lower ceiling height is. The box to the north is facing the river, and that's the living space with a roof light above it. And then the dining room adjacent to the kitchen is to the south, with a terrace close nearby Elizabeth's kitchen garden, where Elizabeth can come up this staircase and treat this whole space as a kind of indoor-outdoor area. This is the view from the living space with amazing you see the rowers pass by and her amazing planting now established in the garden. And the view south towards Winters Hill. And what was a nice surprise when we built this is you are raised up with the building being above the floodplain. And there's a hedge here in the background, which there's the private road runs past, but you look over the hedge and you see the hill, and you actually don't know the passers, you don't appreciate the passers-by or the vehicles driving down. So the next space is Elizabeth's study, which is maximizing any circulation space within the house. This is a desk facing a window, and to the right here is some existing joinery built into new joinery that's within the wall. And you have a view towards the garden. In green is Elizabeth's kind of accommodation area. She has a bathroom, yoga studio, and built-in walk-in wardrobe, which you pass through, with views towards the river from her bedroom. This view from the bathroom with a large reader glass window, and then a view towards the yoga studio. Throughout the house, we used, there was new joinery built, but in her bedroom, and you can see actually here in the distance, that Elizabeth did have existing items of joinery that we then matched in with the new elements of joinery. So the shelving here, or the drawers below her cupboards, that were an existing teak unit that was then matched by the joiner with new doors above, likewise in the kitchen. And there's oak floors throughout the building. This is the yoga studio and her greenhouse beyond. So there are three main kind of routes of access from the building. There's the front door, staircase, and in pink shows where a lift can be installed at a later date if and when it's required. And then off the main living space, there's a processional staircase down to the river. And as I explained before, there's the staircase towards Elizabeth's kitchen garden. All of these staircases were carefully manufactured in steel to be resilient from the floodwaters, but we used Balau treads and Balau handrails, which is a tropical hardwood, which is very resilient if and when it gets wet. And Elizabeth was very keen on that handrail to be in timber, so it's soft to the touch and warm and not cold as the steel. And these show some of the details of how we spaced that timber off the steelwork to give a shadow gap and to allow it to be ventilated. And we did the same detail with the treads where they're sitting above the steel substructure. So then moving on to the cladding of the building, the building is clad in larch with a coating called Centrin Chroma Coat, which was grey in appearance, and Elizabeth was keen on that to contrast with the existing silver birch trees. There were timber corner posts, and we had larger sawn boards between the windows, and then we used narrower plain boards beneath the windows, and that gave a really nice contrast between the two kind of different areas of the elevation. And the windows were custom built in Iroko timber with an osmo stain. And you can see here on the elevation, you have the solid ventilation panel, you have the floor to ceiling flush glass opening, which is lost within the ceiling and floor, and there's a blind box integrated into it. And then on the outside, you have the plain boards and the wide boards, and the plain boards gave a bit of tolerance for the contractor as well to kind of get that boarding working nicely, which you can see in these images here. And on the left here, you see the integrated back box as well, which is just a slot in the cladding to allow them to roost. So in more detail, the windows which were custom had the solid panel, but then the hinged opening door. The hinged it was on a concealed hinge with kind of door hardware. And we sourced a roller blind fly mesh, which we then integrated into the window joinery. And this was we also installed these, they're called shutter dogs, but they're window stays effectively, which had these kind of tiller rudder to stop the shutters moving in the wind. And these, the fly screens, because it's next to the river, they're really important and they work really nicely. And there's also, this is magnetically fixed. So if it ever was to go wrong, you have access and you can repair it. What's really nice about having the solid panel fixed window and the opening, the solid glass and then the opening solid panel means that you do have this real kind of flush finish for the windows. And it looks like you're in the tree canopy being raised that kind of 1.8 meters above the ground. There was one window, most of the windows have an overhang, but there was one window which was facing south, which is that big window in the kitchen facing Winters Hill. And for that window, we integrated an external electronic blind, which is from Tidmarsh blinds, and you can mechanically operate it and you can tilt the angle of each of the louvers to work, and that works really nicely, and it is the only place where the sun really does get into the building, and Elizabeth uses it all the time. There are two additional buildings, which I mentioned before. There's the garden shed with the bird kind of, it's got a cage on the back to prevent birds eating some fruit trees. And then this is the boathouse, both of which are made of resilient materials, so corrugated galvanized sheets and galvanized steel frame. And the boathouse has Elizabeth's canoe slung in the top, and it has plywood panels with this slotted hooks, which allow Elizabeth to hang her bits of garden furniture and chairs on the wall, as well as other things. The doors and the garden fences are clad in oak, of kind of robust material, but also slotted on the boathouse and the shed to allow water to pass through. And they have an Osmo finish on those as well. This is the bird cage on the garden shed, and on the left is the boathouse. So now we move on to the actual construction of the house. This is looking towards Winters Hill and the site before anything has been constructed. And to deliver the project, flooding was a real issue that we actually had to think of, not only for the final building, but also during the construction process. How we could minimize the amount of material that was stored on site, and how we could assemble the building as quickly and efficiently as possible, and minimize the wet trades and kind of other elements. Analysis, there is.
So yeah, this is one of our drawings, customized drawings, showing how we started. So as Fergus said, it's largely a timber structure for the building, but it starts on the ground, obviously, with some driven steel piles, which are hollow steel tubes, 220 mil wide. And those were driven down about 16 meters through the alluvium into the underlying strata. And you can see here they were filled with concrete, and then this mini plunge column was installed on that, and that allowed us to get ever tighter tolerances in the setting out of the steelwork, because obviously the timber above is highly precise. So, and the steel is within normal steel tolerances. So this is the pile. You can see how they have a crimped end, and they're driven in, and then a new section is welded on, and it's driven further until it reaches a set load. Those mini plunge columns are in the far right-hand picture, so you can see them laid out on the site before they were installed. Next slide. And this is the steel frame. So the steel frame, as Fergus said, it's effectively a table, and it has 100 by 100 box section columns with steel beams. I think there were 305 or 254 UBs, all galvanized, and all forming an orthogonal grid under the main load-bearing walls, slightly set in, and then with small stubs that you see at the end. So you actually see the edge of the steelwork as the profile of the I-beam, and you can see in the middle there's a ground beam, rectangular ground beam foundation. So effectively, we have a Vierendeel frame that forms the structure of the building with no cross bracing to get in the way of the floodwater. So the idea is to leave the floodwater and any debris as unimpeded as possible underneath the building.
There were a few holes cut through the steel for some drainage and services to run through, but predominantly the building is very kind of simple below the steel work, and everything else is incorporated within the building. Yeah.
So this is the steelwork installation. So it was all went very smoothly. Prefabricated, obviously. You can see on the left-hand, well, both photos here actually, that galvanized ground beam that ties the central piles together and then gives us the stability structure for the legs.
We also where we connected the steel onto the timber, we put these steel plates to space off the timber from the steel work to, if it ever did get wet, it's ventilated in that zone.
Yeah, so there's softwood joists on their side on top of the timber, so it's 100 mil wide flange. and then, yeah, as Fergus says, it's bolted off, and that allows us to move from the steelwork into the timber by bolting the timber on top of the top flange, and
So
then.
Sorry, Tim.
Sorry,
The kind of actual timber box on top of the steelwork is incredibly simple. It is just this insulated box that is sat above that and wraps in a continuous layer all the way around the building. And then Tim, you can show the.
Yeah, here's the detail of the interface between the steel table and effectively the floor slab of the building, which is prefabricated in timber as large cassette. So they have thin joists which span the full distance. They're about 6 or 7 meters long. They were quite large, with a plywood soffit panel and an OSB top base. That is filled with insulation, and it has noggins, softwood noggins as well, and that forms effectively a large timber table. And then on the left you can see the bottom of the BlokBuild panel, which is a hollow OSB box. What we've been doing recently, and ever more, and this is one of the earlier projects where we started, was using the BlokBuild system, well, helping BlokBuild develop their system to be based entirely on OSB, so with no timber sections in the cassette. This is a typical cassette. Jonathan might want to come in and explain what it is, but.
Yeah, so we digitally manufacture these using CNC machines. So OSB sheet material with the tops and bottoms and the side plates all screwed together, and you can see that central cutout has got a fin. So they're assembled. They're all individually sort of referenced. So we do that in terms of installation sequence, and then they're assembled. With the tops off, we fill them with insulation, then screw them shut. We've got peg detail, which is to fix one cassette to the next cassette, and then a routed or what would become a routed sort of nail plate position. And those nail plates are, I think, a galvanized plate that you fix on. Through this project, we sort of we came through with the nail plates weren't rebaited at the time, so that had a few issues with the external battening, just in terms of having to pack it. So the kind of iterative design has meant that we now rebate those plates, and that helps with the quality management processes as well. So we know that we've got all the nail plates that we need to. They're all in the rebated positions.
So when we started designing the building, we hadn't actually decided that we were going to use Jonathan's system, and we were keeping our options open. And as the building had a flat roof, kind of water ingress was a concern. So the two kind of sides of the building, which are planted green roofs, were laid on a fall, but they were fully ventilated with the zinc central roof in the middle. And you can see here that continuous ventilated layer underneath that top surface with a liquid applied membrane with the green roofing above and the zinc roof in the center. There's the green zone, which is kind of ended up being Jonathan's system. And then below that is a clear void for the MVHR ductwork and servicing, and then the finished plywood layer underneath. And you can see where it works really nicely with this building, how you have that continuous insulation layer with the ventilated zone around the outside between the external roof finish and the cladding finish. And that also allowed us to vary the internal finishes from the bathroom to the kitchen to other areas. And we use sand above the cassette to dissipate the heat and allow for the underfloor heating.
Yes, this is a sketch, one of our sketches showing the ties and layout of the floor cassettes. So they're generally done in two spans, so from where the mouse is, all the way north-south on the drawing, and then placed east-west, about the width of a lorry bed, so about 2.5 meters wide. And with,
no, I was just going to say for the house, the strategy was that the floor and roof cassettes were made by Jonathan, but not loyal to Jonathan's system. They were much larger, but the wall cassettes would be used kind of Jonathan's nested computer cut.
Yeah, so this is, I mean, perhaps Jonathan can talk us through the design process with these, but obviously they're staggered in 2 layers because sheet of plywood's only 2.4 meters high, so we have to have.
Yeah, but then the larger panels. I mean, this is just Jonathan.
This sort of shows the floor panels that we were making up, and these were sort of made using the fin joists and softwood noggins and then insulated. But we've got a limited sort of size in the factory, and we don't have the sort of butterfly tables that larger manufacturing facilities have, which is why we predominantly use kind of 600 by 1200 cassette sizes. So we made these larger floor cassettes, and I think through the process of making them for the floor, we went back to Price & Myers, Tim's team, and reduced the size of the roof cassettes. The wall cassettes were going to be our standard, and it was, you know, based around access. You can see there the floor cassettes arriving, not much room to get those down. And then the wall cassettes are much more sort of manhandleable, so 1200 by 600 minimum size. You can see these kind of being craned into position off the lorry, which is it's a really quick way of doing it, already wrapped in the membrane. The membrane was factory applied, taped at the sides, and then as we were installing them onto the steel, we used tape to tape the joints, just making sure all of that was in place and hadn't been damaged.
I think what you can also see in this image is the timber sole plate, which the cassettes were then connected onto.
And also the lifting plates, which were screwed into the top of the fin joists to allow us to lift them up and place them directly side by side. Yeah, there's the straps on the lifting plates.
And there was a connection panel left off to allow you to screw and bolt each of these individual panels together. And then that was installed once everything was positioned on site.
And the top skin was left over long, as I remember, and as it sort of came down, it connected with that connection plate that had been left off and then fixed through.
And then you've sort of spoken about that, but the kind of Jonathan's using the ground slab cassettes weren't, as we said before, kind of traditionally Jonathan's system, but the actual digital cassette, there's a kind of design process where we have the kind of architectural designs and 3D BIM model, which is then sent as a coordination fabrication model to Jonathan and his team, and also Price & Myers. And then this is just frozen. Sorry, here. And there's a kind of crude block model, which is then to be inhabited with the cassettes and the script. So on the left, you see the zones, and then on the right, you have the fabrication model.
Yeah, so we go through a process of defining the structural layout of all of the OSB cassettes, and then that markup effectively is done in 3D on the Rhino model. And then the actual fabrication model is then run through another script that produces all the parts, which as you can see on the right-hand image, that feeds information to the CNC cutter.
So kind of the structural openings are checked, the position of various cassettes to also double check against services and openings. And then finally, once Jonathan's given the production model, it's reviewed by us and given the okay, it's then put into manufacture.
You can see the sort of the way that we do it. So we machine it on a flatbed CNC, 3-axis, and then it's assembled using those parts that are cut out. There's very minimal sort of waste. A sheet produces 50% of a cassette, so 2 sheets is a full cassette. And yeah, they go together pretty quickly using on site using nail plates and pegs. So the pegs are a plywood peg that they just knock in using a mallet, and then the nail plates are sort of rebated or routed out on the joint lines of the position that they need to be in. They actually weren't on this project, so as part of the design process, we've now started routing those out. Similarly, with the floor cassettes and the roof cassettes, they were on this project, they were built using fin joists and noggins. We've now sort of designed that to be a digitally fabricated cassette similar to the wall cassettes using bolted connections. So that has also sort of become a lot smaller and more sort of precise in manufacture.
I think that was really interesting on this project, kind of all along learning at the various stages of how the system could be improved and what was the contractor Philium were finding difficult on site. So once the membranes were all installed over those nail plates, you couldn't actually see the 3 mil kind of thick plate, which then made the second fix and the battening and the cladding that much more difficult. And that kind of feedback and response enabled Jonathan to improve the system and use these kind of nail plates now as Jonathan, you use them now as a coordination to make sure the cassette is the right way around in the right position as well, don't you?
Yeah, coordination, but also quality control, just to make sure that, because before we were relying on the sort of contractor to install the nail plates as per drawing. So now, you know, we do a check as we go along, and if as long as all those rebates are filled, we're kind of to a certain screw pattern, we're happy with that.
And once the wall cassettes arrive on site, they go together very quickly. And you can see here on the right, the views are starting to be framed. That's the view from the kitchen towards Winters Hill. And the white membrane, the vapor barrier internally, and the black one, which was Novia, I think, Jonathan, which was on exterior, the breather membrane. And you can see there stacked up some additional cassettes ready to be installed and put in position.
And we use the cassettes as lintels as well, so there isn't any kind of steel lintels or glue laminates. It's a cassette with a number of fins internally notched through the front back skin that create the lintels.
One thing we did on this project was most of the external walls were in the cassettes, but a few primary walls, but most of the internal walls were actually then built in situ as stud work to allow services to run through. I think what we learned from this is actually, in terms of sequencing and buildability, it would have been better to have actually more block build cassettes as the primary structural walls while the building was going together. But obviously there are certain locations where on-site stud walls are more necessary.
It's more convenient.
Yeah. So this is the building once the cassette walls are in place, and then the roof starts to go on, and starts to be.
Again, these are modular cassettes, which now differ a bit. These have pin joists inside them, and the system now is fully stress skin, top and bottom section.
We actually reduced the size of the roof as well, because the learning we had from the floor cassettes that we've made up was just that they were too big for transport, but also for handling in factory. So, and then as we've designed them into being CNC cassettes, they're now sort of a maximum width of 600, so much more sort of handleable on site.
And then once all the membranes were installed and the walls in position, it was then for the kind of final fixes of the cross battening for the cladding. The zinc roof was then prepped and installed. The roof membrane was placed, windows put in, and then finally the galvanized steel staircases and terraces were put in. And then the final house, which was, again, as we said before, predominantly timber, well, all timber above the floodplain, and then steel and other resilient timbers below that level. And the house does flood. This was a photo Elizabeth took kind of a year after, or recently after construction, with swans swimming underneath the building. But it's a real kind of idyllic space, and Elizabeth has inhabited the garden and planted it beautifully. You see a rower swimming past or rowing past, and there are lots of happy users inside the building. Elizabeth's dog looking out the window, but it's amazing how it frames the views, and you feel really part of the garden and the landscape. Thanks very much.
Amazing. Amazing. I'm sorry, I want to become Elizabeth. If she wants to vacate that position, then yeah, I want to come and have her life. But I just so love the attention to detail and the way you all used it to learn, you know, as you went along. So I know we've got some questions and answers coming up, but yeah, no, is there anything else, you know, like Jonathan and Tim to sort of add? Because I know architects always explain everything so beautifully, but is there anything that you think we didn't cover, you know, during the presentation, or that you'd like to?
Well, I think it was covered well. I mean, there's some questions we could go through with some of the points about technical things, but that's good presentation, Fergus.
I think one thing I would just add is that it was interesting using, or kind of starting to use, Jonathan's system on this house, and since we've done another house, but houses like this can be used as a test bed to explore a system. And Jonathan has been building his system in Bristol on some low-cost housing, and we're also talking together about kind of other housing schemes, and a house like this enables you to explore something that otherwise perhaps it wouldn't be possible.
Right, let's go to all the questions. So first of all, I'm going to start at the top. You know, what's saying bat boxes, because that came up. I love that installation, you know, that insertion in there. But one of our questions is, you know, what about the bat droppings? I mean, they're concerned about the longevity, but I mean, bats weed down the side of buildings.
Well, the bat box is kind of self-contained behind the cladding, so the bat can only get into that bat box area. I don't know how many bats would be in the box, but I think there's enough room for quite a lot of droppings to kind of accumulate before you would need to replace it. But also the cladding itself has a lifespan, so timber cladding doesn't last forever, and when I imagine that is replaced, the bat box would also maybe be replaced as well if it's needed to.
Oh, thank you, Fergus. Green roof question. With the insulated details, was the saturated weight of the green roofs factored into the cassette design? I think that's probably for Tim and Jonathan.
Yes, yeah. I mean, those things have a design, you know, specified loading, which takes into account them being saturated. So that's what we used to do the sums. Yeah.
Yeah. But the roof itself isn't, I mean, it's a wild flower roof, but the actual kind of substrate for it is only about 120 mil or 100 mil thick. So there's not a massive amount of weight up there. But I guess when it does get saturated with rain, it does get heavier.
Yeah, I mean, they tend to be aerated with brush bricks, those sorts of mixtures. So they're not quite as heavy as soil in the ground. Yeah, they're more.
But all taken up in the structural calculations, and then obviously designed, you know, not just, yeah.
No saggy roofs or cracks reported. No.
I did like the detailing there where you've got actually, you know, with the air gap underneath it, you know, so, but yeah, I'd be interested to really then get into the details of that air gap and the bottom of it. It looked like there was some like noggins up, but again, it looked so good. Where are we going now? By using all wood-based construction systems. Sorry, I jumped one. How long did the construction phase take, and particularly the block build part?
On site, we were about 6 weeks. Off site, we were sort of between the design process and the manufacture. It was sort of 8 to 12, working sort of alongside delivering just in time. So it kind of, the manufacture and the delivery and install were happening kind of all around the same time, but the on-site period was about 6 weeks.
And was that to deliver like an airtight, watertight frame? That's
the sort of structural shell with the openings wrapped in a membrane internally and externally, ready for the sort of for the first fix and windows and cladding. So yeah.
Mm-hmm. Just as an additional question, so how do you keep things dry during that process of that 6 to 8 weeks?
There's a lot of temporary covering and uncovering. We generally get, I mean, all the cassettes are delivered just in time, so so the floor cassettes arrive, then a big screen goes over there, which we sort of reuse, and then the wall cassettes we wrap in a membrane as we go, just lapping we've got a sort of visqueen that goes over the top and drapes down the side. So membrane on the faces, and then a temporary protection along the top of the wall plate. Similarly on the roof. So a lot of temporary protection. We've started using liquid applied membranes, which is a lot quicker. We can do that on site. We can do that on site, or we can do that off site. Just depends on drying time and the weather. So yeah, that helps as well.
No, thanks, Jonathan. Okay, so interesting that people are thinking about hygroscopicity. I can never say this, hygroscopicity. And so by using all wood-based construction system, would it be safe to say that the system is hygroscopic? And if yes, why do we need a vapor membrane? Probably one for you, or Fergus or Jonathan.
Well, I'm not 100% sure what hygroscopic means. I mean, if it being timber allows the building to breathe. So we have the MVHR system inside the building, and we have opening windows, and the whole kind of build up is quite breathable. But having the vapor barriers and the breather membrane makes it that much more robust. So that's why we included them. And the OSB is, which I don't think we've talked about that much, but it's kind of got a certain level of breathability as well. The OSB is sourced from, I think it was Northern Ireland, wasn't it, Jonathan?
Yeah, the UK mills as well, English mills as well.
Yeah.
The vapor control, I suppose, controls the sort of level of vapor passing through, but also if we didn't have that, you'd have the condensation sort of sitting within the wall. Yeah.
I mean, there is some seasonal change. I mean, as with all timber, there's some dimensional change, but it's pretty limited within the confines of each cassette. Shrinkage and expansion due to seasonal changes in moisture in the timber. Well, we've had no issues with finishes cracking, have we?
No.
The layers.
So this is the benefits of using engineered timber in the first place, that you don't get that as much dimensional change.
Reduction of that, yeah.
Yeah, and obviously having the vapor control there on the inside, you're stopping any water or moisture within the building actually getting into the fabric to start with, and then having a sort of a vapor. It's not vapor control, but the membrane on the outside, you're allowing that to sort of not only escape actually through the wall if there is anything in there, but that also acts as a wind tight layer to actually then stop the heat being taken away from the actual house, so the wind washing. But let's move on. As the construction is unusual, although I'm sure you would disagree with that, Jonathan, were there any issues with getting structural warranty and building control sign off?
No, we've got a sort of type approval on building control, which is just we've gone through the details with our provider to sort of make sure they understand all the typical details, and then with warranties we're BOPAS accredited, so they're recognised by a lot of the sort of major A-rated lenders and insurances. So that gives us a 60-year assurance scheme, or assurance on the system and the details behind that.
Yeah, you have to go with the right warranty provider. I mean, some don't recognize it, so you have to but there are plenty that do, as long as you engage them early.
Yeah, I think that's the thing, is engaging them from the sort of get-go rather than retrospectively. It's definitely possible, and similarly, they just do an audit 3 or 4 times during the build process, and a report on that, and anything that's missing or that gets flagged, you just have to respond to pretty quickly.
Yeah, thank you for that. What was the insulation the cassettes were filled with, and what sort of U values were you getting? And also, did you measure the air tightness of the building?
We did measure the air tightness and the insulation inside as rock wool to get a continuous kind of uninterrupted insulation to improve the UV. I can't actually remember off the top of my head what it was, but we actually had insulated plasterboard inside the building on top of the actual cassettes to raise the U value that much higher. But Jonathan, just the cassettes on their own, do you remember what the U value is?
236 is 0.16, and that's using 200 mil RAW45 insulation.
But that depends on how thick the cassette is. So
yeah.
And that's what your kind of the compromise is. If you want a thicker cassette, you can get a higher U value.
Yeah.
But the best way to keep the width down is to then have another layer of kind of continuous insulation internally or externally.
0.09 we're achieving with the 336 cassette. So it just we changed the spec of the insulation or the dimension of the cassettes to sort of suit the requirements.
Oh, thank you. Any specific timber treatments needed for the scheme?
Well, the cladding has that centering chroma coat finish, which it was a fire treatment and also weather needs to be reapplied. Other than that, most of the windows would have had an osmo treatment, and I think the decks might have been just actually left to sort of weather and breathe, and then the handrail had another osmo treatment on top of that.
I think the sole plates of the steel are tannalized. Supported.
Thank you. And can you explain the key benefits to the BlokBuild system versus a standard I-joist panelized construction system, which I'm assuming they're saying like, either building on site?
Well, from our perspective, we had a detailed model that was then put into fabrication to a high level of accuracy. So as if we're happy with what we're issuing as that coordination model, we can expect that to then be transferred into cassettes and because it's computer cut, there's minimal wastage, and you then get a kind of 3D version of the digital clone.
I think it's quite efficient structurally because the material that you would have there anyway, the OSB sheathing on a timber frame is pulled into use structurally. So you're sort of deleting the structure, if you like, and making the surface of the block be load bearing. So we like it from that point of view.
Thank you. This is just more about the water. So how do you determine the flood levels or the precise water levels that you worked with?
River modelling and the flood risk assessment was part of the project.
That's required at planning. So a flood risk assessment was submitted with planning, and they have known points along the river which have certain flood levels, and then they take an average from those two known points, which then govern what your level at where your site is.
Thank you. Probably one for Tim, this. Do the block cassettes act as a two-sided stress skin to give shear support above the steel table?
Two-sided stress skin. Yes, I mean they are. The diaphragm panel on the face, which gives you backing stability, and then the load is shared between the truss ribs. There's one on either side of the box, and there's one in the middle generally, but we can introduce additional ribs to provide more structural support. So often, Jonathan mentioned people are using it as lintels. So we've done that before, where we've added additional parts in, but also reinforced it for torsion and other things. So it's quite adaptable structurally.
Thank you. There's lots of questions coming in. They're flooding in. And this is. I noticed you had a breather membrane on the external walls. Did you need to wrap underneath the floor cassettes between the steels? I think you showed this really well in the presentation, but do you want to just confirm that?
We did. We wrapped the cassettes. They were wrapped off site, and then the joints were sort of taped once we'd lowered them into position. And the membrane, the sole plate was painted with a liquid membrane at the sides and the bottom.
Thanks, Jonathan. And I don't know whether this is probably for you or Fergus. Did you consider cellulose insulation over mineral wool for the cassettes, or is that actually linked to your BOPAS accreditation?
Yeah, we've tried to steer away from BOPAS accreditation, but also BBA certificates on the cellulose and fire ratings. We've kind of put one product through at the moment. We're trying to put other products through, but it really depends on the certification of the actual product that we're looking at, and the site specific sort of requirements as well.
Thanks for that. What is the height restriction for wall panels, and would extra structure be required if it was a two-story?
I actually built a 3-story one recently.
Yeah,
but it comes down to the module of the sheet, which is 2.44 meters. So the way we do that is we in alternate bays we overlap, we stagger the panels. So it kind of brings in. This was to use large format panels, which I don't think we've ever used.
That's a call out for a new project. Was the main contractor involved in the project, and how did the communication work? Because obviously the communication works well between the three of you.
Yeah, there was a main contractor, Philium, and Jonathan was their subcontractor, but we already had a relationship with Jonathan, and that worked well with their next fix. But Jonathan, your team installed all the cassettes on site and kind of managed all of that side of things.
Yeah, we come on as a sort of specialist subcontractor. We've worked with Philium again after this project, so I think it went well. But yeah, we come in and install the structural shell, and then trades can come in sort of and follow on. So our period on site is relatively short.
And we're drawing to time limits. 2 more questions. So I know the embodied carbon was assessed, because a question about that. Was the embodied carbon for the project assessed? And if so, how did it perform? But I suppose I'd add to that, actually, what was assessed? Which of the bits did you actually include in the assessment? Because you did give a carbon figure.
We assessed the whole building for kind of a carbon calculation. We kind of calculated the amount of steel used, glass, timber, actually down to kind of the amount of timber in each of the cassettes as well. And Ben in our office has developed a kind of in-house carbon calculator, which we're using, which is a series of spreadsheets to then analyze each of the buildings that we're doing, and also help us inform our designs and make decisions early on. So we're retrospectively analysing buildings for good and bad. And actually, there are some surprises there where lots of architects are quite scared to do that. But actually, lots of your hunches and assumptions related to that are often correct. And March House, one of the reasons why it performs so well is that it doesn't have a big concrete slab, and it sits lightly on the ground. And there are these narrow piles, and there's this steel work, but then above that, it's all timber.
A lot of it depends actually on wastage. We are very efficient in using the parent material, so there's not much offcut. So that's another thing that works well in the system if it's nested efficiently.
Yeah, that was really good to see, and the iteration as you went all the way through. One final question on cost, because people are saying, do you know how much it is roughly per square meter, or the price of the things? Could it be an answer to some of our social housing problems?
I think in that we are working across sort of different types of projects. So private residential and social housing, it could be an answer. Yeah, it's not it doesn't have it's not pigeonholed as an exclusive system. It can be used, and it's been used in different sort of ways with community-led housing, and community factories actually manufacturing it as well. So
I think also it's when using the system where it works best. So for the walls, it works really fantastically at the moment. And on March House, we didn't use it for the floors and roof slab, but actually since we have used it, and it's where it's best used, and allow you to have services and other things through it.
Thank you. So a huge thank you for the three of you for sharing that, amazing sort of talk through the whole project. If you want to know more, there is a case study on the Timber Development UK website. If you'd like to come and join us on the 10th of May, we're with Greyfriars Charterist Centre, the UK Hardwood Storage Building on the 7th of June, and Fenland Black Oak on the 12th of July. So a huge thank you to our speakers and to our audience. And we look forward to seeing you next time. And if you have a project that you'd like to enter into the 2023 Wood Awards, we'd be delighted to see your entry. And with that, we'd like to say good afternoon all.